Hello, today I am going to discuss about the PLC input image memory, output image memory, as well as the input-output energization effect on the virtual switch as well as virtual output coil. Okay, sometimes people call input image memory as input image element. Similarly for the output image memory. Okay, so when there is a current flow through the circuit and then flow into the PLC input card, it will energize the PLC input card internal LED and its internal load. When the input LED was energized, it will cause the input image memory to be updated with 1 in its relevant bit number. In this case is bit number 3, which correspond to input terminal 3 here. Okay. As for the output card, when the relevant virtual output coil is energized, this will cause the PLC output card internal LED energized too. When the PLC output card internal LED is energized, it will cause the output image memory to be updated with 1 for its relevant bit number. Okay, let me zoom it. Okay, for example, in this case, this terminal point 27 will be updated with bit number 1. Okay, this point 27 falls under word 1. Okay, this portion belong to word 0. This portion belong to word 1. Okay, word 0 bits and word 1 bits. Okay, so the word 1 bit 11 will be updated with 1. In summary, okay, when this start push button is pressed, the current will flow through this input terminal number 3 and energize the PLC digital input load as well as its internal LED. Because the internal LED was energized, the input image memory will be updated with 1 for bits number 3, which corresponds to input terminal 3. And this will cause the virtual switch for this particular, which is relevant to input terminal point 3, to be triggered from normally open to close. Okay, let me use a pen to draw it. Okay, this will be closed. All right, when the input terminal 3 is energized, what happens is its virtual switch will be triggered for normally open to close. If let's say originally this is a normally closed, then it will be energized from normally closed to open. Okay, so this will cause the virtual power to flow through this run. Thus will energize this virtual output coil. Remember, I use the word virtual. Okay, why? Because it is not the physical wiring. It is something that we cannot see or touch. It only exists in the memory. So I use the word virtual. Okay, because the virtual output coil, okay, output coil, this is a switch. This virtual output coil is energized. This will cause the PLC digital output internal LED to be energized. What happens is it will cause the output image memory to be updated with 1 for its relevant bit number. In this case, it's a bit 11. Okay, so this is a sample program of the PLC ladder logic diagram. So when this push button is wiring as normally open, as you can see the wire here, so it's normally open. This stop push button is wiring as normally closed. So what happened is when this stop push button is pressed, okay, so it will trigger from the switch from normally open to close. So the current will flow through here and then will flow into the PLC digital input card and hence will energize its internal load and its LED. And the current will exit through this common terminal point and then back to the neutral line. Okay, since its relevant LED is energized for input terminal number 6, what happened is this is a input terminal number 6, number 6, which correspond to this. This will cause the virtual switch trigger from normally open to close. Okay, so it will cause this normally open virtual switch to trigger from normally open to close. And this output contactor, which is this one, virtual output contactor, is originally normally closed. You can see this is now normally closed switch. So when the switch virtual switch is closed, you can see the blue color is highlighted surrounding here. Okay, and this one also will highlighted, which indicates the switch is closed. Okay, so the virtual power will flow through here and then flow through this point. As we know, the stop push button is wired as normally closed. So the current always will flow through this circuit and then will go through terminal point number 7 to energize its relevant internal load and LED. This will cause the virtual switch, okay, to trigger from normally open to close always. So this virtual power can flow through this line and then energize this virtual output coil. And this virtual output coil will trigger its relevant virtual switch from normally open to close and it will continue to latch the circuit. Alright. And because this virtual output coil is energized, what happened is this PLC digital output card internal LED will be energized too. Okay. So this will cause the digital output internal switch trigger from normally open to close. And then this current will flow through this line and then will go through the internal switch and then flow through this circuit to energize the external coil, which is the external load. Okay, this external coil once energized, it will cause this normally open, okay, contactor to close. So this contactor, three-phase contactor, is connected to three-phase power supply. So what happened is the three-phase power supply will go through the contactor and then will flow through this thermal overload relay and then will go to the three-phase motor of the pump. Hence, we'll start the pump. Okay, so that's it. Thank you.